This video starts our next unit, which is on atomic structure and some of the different atomic concepts that we have. So to get us started, we actually want to review a little bit about what you already know about the atom. If you think about the atom, it is the basic unit of all matter, and we know that it contains some subatomic particles. For instance, we have the proton, which you know is positively charged, and it's located in that central structure that we call the nucleus. You also have the neutron. Neutrons have no charge and are also located in the nucleus. Lastly, we have electrons, which are negatively charged and instead of being located inside, they move around the outside of the nucleus, kind of like in the picture that you see there. Now, we can talk about several properties of subatomic particles that you maybe haven't discussed before, but we need to keep a couple of things in mind. First of all, we need to keep in mind that we are dealing with very small numbers, both when we talk about mass and also when we talk about the electric charge that these have. Therefore, it's not very convenient to use SI units when we are discussing them. Quite honestly, even with scientific notation, it is a little too cumbersome for us to work with. So instead we use their relative relationships, in other words, how they compare to each other, which makes life and the use of these much easier for us as scientists. Typically for mass, we actually have a special mass unit that we use at the atomic level, and that is called the AMU, or atomic mass units. All of the other masses, like the mass of the proton and the mass of the neutron and electron, are measured relative to this value of an AMU. But we'll actually even simplify it a little bit more than that. So what I want to do is I actually want to go through the subatomic particles and kind of talk about some of these characteristics. So we're going to start with the protons. Protons have a relative charge of a positive 1. And that positive is very important. The mass in terms of AMUs is 1.0073 AMUs, but its relative mass, and the mass that we will consider it to be in this class, is 1. Now, the number of protons that we have actually identifies the element that we have, because the number of protons is also equal to what we call the atomic number. And the atomic number can be found on any periodic table that you're given. So if you're using a periodic table and you need to find out the number of protons, all you have to do is look up the look up the atomic number to determine the number of protons. The second type of particle are the neutrons. Okay, neutrons have a charge of 0 because they are neutral. Their mass is just over 1. As you can see, it's a little bit bigger than a proton though. And therefore, because it's so close to 1, we still consider it to basically have the same mass as a proton, about 1. Now, because it does not have any charge, neutrons contribute only to the mass of the atom, not the charge. So as you can see from here, neutrons and protons determine mass. The last one are the electrons. Electrons have a relative charge of -1, and their mass is very small. Okay, it's less than a single AMU. In fact, it's a lot less. So because of that, we will say its relative mass is 0. But it is important that you understand that electrons do have mass. It's just that we tend to ignore this mass when we determine atomic masses. The number of electrons, though, is the major contributor to determining the charge an atom may have, if it has any at all. The number of protons in an atom can't change, but the number of electrons can fluctuate. So here is a summary of all of the information that we just discussed. Of this information, the most important ones that you want to key in on are the relative charge, and the relative mass. We will be using those in the future, and it is important that you actually remember these so that you're able to perform calculations and determine characteristics of atoms appropriately. So in the next video segment, what we're going to be doing is seeing how we can actually use these bits of information to determine certain characteristics about our atoms.